Hi guys, today I'm going to work through the examples from exercise 3.4, which is transformations, and it's from your Jacplus Year 12 textbook. So I've pasted here the general rule for transformations that has been given to us in the textbook, and it's actually pretty handy to have that in your book, and so that you can refer to it quite easily. Now I'm just going to label these 1, 2, 3, 4, 5 and 6, so it's easy for me to point out which one's which. So the first worked example that we're given asks us to describe the transformation that has been applied to the graph of y equals x squared in each of the following. Sketch both graphs on the one set of axes. Okay, and then we have to find the image of the point 2, 4 after it has undergone each transformation. So look, I'll start with y equals 2x squared. So I'm just going to draw y equals x squared. So obviously this is not drawn to scale. And then if we're drawing y equals 2x squared, we know that that's going to make the graph skinny out. So it's going to look like this, y equals 2x squared. Now, if we refer to the list over here, we see that this 2 is represented by A, and I should probably color code them. So it's represented by A, and this is telling us it's been dilated by a factor of A parallel to the y-axis or from the x-axis. So you don't have to say both of those. You can say parallel to the y-axis, or you can say from the x-axis. I'll write both just so that we know that either one is fine. So dilated by a factor of 2 parallel to the y-axis or from x-axis. There we go. So look, let's look at the next one, and I think they have made a little mistake here because I think it's meant to be 2x all squared. So in this case, I mean, you could square the 2 and square the x, so you could get 4x squared, but let's leave it as it is so that we can look at another value here, and that would mean that it's related to n. So this one here is looking at this rule. So this is going to be a dilation of 1 over 2, so half in other words. So we can say, well, for B, it's dilated by a factor of 1 over our value there of 2. And notice that this is now parallel to the x. Or from the y-axis. So if we were to draw this, then, well, y equals x squared, that can be here. And then our, it was y equals 2x squared. So in other words, y equals 4x squared. So that means, well, again, it's going to be like this. So I think I forgot to do the 2 points there, so I'll do that as well. Y equals 2x squared. So the point was 2, 4, and it says to tell us the image of the point after it's undergone the transformation. So let's do that. So for the first one, it was 2, 4, and that is a dilation factor of 2 parallel to the y-axis or from the x-axis. So if it's from the x-axis, then it's going to be affecting the y value. So we're going to be timesing the y value by 2. So if I were to just sort of use one of those, I think for me I usually use the from, so I'd say from the x-axis, and I always remember that the dilation and reflection affects the opposite. So that means that we're going to get 2 still for x, the x value is still 2, but this dilation from the x-axis affecting the y, so the y value becomes 8. So for the next one, dilation of factor of half from the x-axis, or parallel to the x-axis, it's from the y-axis. So our point 2, 4, well, we're going to be multiplying by half, and if it's from the y-axis, it's going to affect the x. So for this one, we're going to get 1, 4. Right, so that's B. Let's go to C. So C is negative x squared. So I might just draw it first. So here's y equals x squared, and you already know from even year 10 or 9 that if it's negative x squared, it looks like this. And we'll refer back to the transformation rule, but really, I mean, this is a pretty easy one. So for this one, it's number 3. If A is negative, the graph has been reflected in the x-axis. So I'll just put a little like blue thing there to show that the negative would go there. So reflected in the x-axis. So we can say our transformation is just reflected in the x-axis. And what we see is that, well, if you have a certain x value, just say that's a 2 over here, well, your y value would be 4 on the purple graph there on y equals x squared. When we reflect it, well, on the green graph, well, it's negative 1 times 2 squared, so it's negative 4. So the point is that when we reflect in the x-axis, we're affecting the value of y. So dilation and reflection affect the opposite, and that's why I prefer to say from the x-axis and from the y-axis when we're talking about dilation, because then we can remember dilation and reflection as affecting the opposite. So our point 24 reflected in the x-axis is going to affect y, so we're going to get 2 and neg 4. All right, let's see what is next. D, so y equals x plus 1 squared. So I'll put this down here. Okay, so again, our graph of y equals x squared. And you know from transformations that we move in the negative direction by 1 unit. So this is connected to the x. It's in the brackets with the x there, so we go the opposite direction. So this is going to negative 1. So really, I mean, you can see that we're moving 1 unit in the negative direction of the x-axis. So this is our h value from, I'll go back to the rule. So this h value here. So each x value has no, so we've got this. So the last one there. So this is going to describe the transformation here. We can say translated 1 unit to the left. And well, in that case, we've got the 0.24. The translations affect the same x or y. So we're talking about 1 unit to the left, so it will affect x. So it means that we're going to be subtracting 1, so it would be 1, 4 would be our new point. And look, the next one I think is the same thing, only that it's a -2 instead of a +1. So look, I might just do that on the same graph. So -2 would mean we're going to there, and we're moving 2 units. So y equals x minus 2 squared would be translated 2 units in the positive direction of the x-axis, or just 2 units to the right would do. We said 1 unit to the left for the blue one, just another way to say it there. And now, well, our 0.24, so 2 units in the positive direction of the x-axis, it means we're going to get 4, 4. So it's going to be affecting the x value. This was affecting the x value as well. So the last one now is our vertical shift, and we can see on the equation there that that's our plus k value. So if we're talking about the plus k value, then we are going to be moving up and down, and in this case down. So let's draw that one, x squared minus 2. So here will be y equals x squared, and from the parent graph -2 we're going down 2 units, y equals x squared minus 2. So this one we could call it translated 2 units down, or 2 units in the negative direction of the y-axis. So our point 2, 4, and this is another translation, so it's going it's affect the same, so it's going to affect the y value. So I'm going to minus 2 there, so our point becomes 2, 2. So there's that. Now I think I just saw I had highlighted the wrong thing previously, so that one we just did, which I coloured in that blue colour, is the k value. So I accidentally included that in the previous one, and the translations left and right, or affecting the x values, is that. All right, so that's the first example. This is quite a handy, as I said, so you might like to write that down in your book and just refer to it as you're working through this chapter. Now, I'm going to do worked example 5, and I'm going to use the that equation again so that we can see and describe each of the transformations pretty easily. So let's write this out. Y equals, we have a f of n x minus h plus k. So that's just the equation that we saw above, the one that I said was pretty handy. So f, this is f of x, like this is f of x here. So now that we've got that, let's make this look the same. So y equals half, and then we've got 2, and then x plus 3 on 2. I'll try and put it directly under. So let's try again. Half 2x plus 3 on 2, and we've got a squared minus 4. So this is our equation here. And now we just need to see which values are which. So there's our a value there. The n value is going to be the 2. Obviously x is x, I'm not going to highlight that. Then we've got this h value here, and of course the k value. So now we can just describe the transformations accordingly. So the first thing, so first of all we will talk about dilations and reflections. So it's like when we do the table of transformations. If the order is not given to you, you always would do, like BODMAS, you would do division and multiplication first, or brackets first, and then division and multiplication, followed by addition and subtraction. So in transformations, dilations and reflections, they are our first important things, and then we worry about translations. So up and down, or left and right. So let's see, the first thing we can say, dilated factor of half from the x-axis. So if you look back up to the list up the top there, that tells you what each of them are meaning, what the a, n, h, and k mean. We see that the a value is the dilation factor of half. So that's what that pink one is there. So I might actually colour code it as well, so it's easier for you to see which ones I'm talking about. So the next thing I'll talk about is the yellow, the n. And remember that the n value is going to be 1 over whatever the n value is. So this is a dilation factor, also half, 1 over n, 1 over 2, because n is 2. And this time we are from the y-axis. So it's a little bit annoying that they're both half. It's just make sure you know which one's which. So this one, the purple one, or pink, from the x-axis, the yellow one from the y-axis, and the yellow one will be 1 over that n value. So the next thing we can look at are the translations, and it doesn't matter which order you do them, but it kind of makes sense to do it in from left to right. So I'm going to do the green one next. So that's talking about our translation, along the x-axis. So we can say translate 3 over 2 units to the left, or in the negative direction of the x-axis. And of course the last one being our up and down, so the -4. So now we can say translate 4 units down. And look, these are interchangeable. I could say 4 units in the negative direction of the y-axis, or I could say 3/2 units to the left. It doesn't matter. I'm going to write one of each, so then you see that they both mean the same thing. Remember also that we could have used the words parallel, so this one would have been parallel to the y-axis, and this one would have been parallel to the x-axis. But as I said, I choose to use from, because then it's easier to remember that dilation and reflection affect the opposite and the translation affect the same. Let's move on. So the last one for this exercise is telling us to find the rule of a new graph. So we have g of x is root x, and I'm going to use mapping for this, and I suggest that you do use mapping for these. I think it's really a good method, and you can really build up the equation well, or build up the point really well. I think the understanding is easier when we do it this way. So what I'm going to do, g of x is some graph, and well, obviously it's a root graph, so it looks like that, and it has a lot of different points on it, an infinite number of points, but I'm just going to choose a random point. I'm going to call it xy. So remember in the first worked example from this video, we had a point of 2, 4. And if we dilated it or reflected it or translated it, it meant that we changed those values here. Well, that's what we're going to do with this point xy, and that's what we do when we use mapping. So I start with xy, and then dilation factor of 3 from the x-axis. So no, it's not, sorry, translation 2 units, right, sorry, I missed that one. So just to be sure that we want to do it in the order that's given to us. So when we describe the transformations, we would talk about dilations and reflections first, but when we are building up an equation, we always go in the order that's given. So definitely the translation 2 units right. So if we're translating 2 units to the right, that means that, well, our x value is going to become x plus 2, but the y value will not change. So that's the first thing. So I've changed the point so that xy becomes x plus 2 comma y. So my x values all go 2 units to the right. So if this x value is 1, it would mean the new x value would be 3. Let's now do the next thing, dilation factor of 3 from the x-axis. And be careful of the wording here. So from the x-axis means it affects y. So it affects the opposite. So now I take this point here. So we've already gone 2 units to the right with every point, x plus 2. And now we're going to be dilating a factor of 3 from the y-axis. So we still have x plus 2, but from the y-axis, from the x-axis, we'll be affecting the y value. So I'm going to write 3 times y. So that's what I've got now after I've done that green bit. Now, let's choose a new colour. Dilation factor of half from the y-axis. So if we're doing from the y-axis, we affect x. So remember the from, it means we affect the opposite. So our point x plus 2 comma 3y. Now dilation of half from the y-axis becomes half brackets x plus 2. So the whole point, not just the x, you need the 2 as well. It's now x plus 2 comma 3y. So that's now the dilation factor of half from the y-axis. Let's get a new colour. Translation 1 unit down. So 1 unit down, this is a translation. It means it affects the same. So down will affect the y values. So we take half x plus 2 and comma 3y minus 1. So that's our new point. Oops, I didn't write the old point. 1 second. So that's the old point and mapping to the new point. So half, there's so many brackets here. Half x plus 2, and we are translating 1 unit down, so comma 3y minus 1. So now we've got like this. And now, well, the last thing that they have there is a reflection in the x-axis, and remembering that a reflection affects the opposite as well. So our point that we've got here of half x plus 2, comma 3y minus 1. So now reflecting in the x-axis means we're going to affect the y values, so it's going to become half x plus 2, comma negative 3y plus 1. So now we've got all those transformations accounted for, and now we have to go about making the new equation. So let's just neaten that up. So our final point after we've done all the transformations is this. So that's the final point. Now, what we can say is that this is the image point. So we can say x image, y image. So this is the new point that we've made from doing all the transformations. And that new point is given by half x plus 2, comma, neg 3y plus 1. So we have taken x, we've added 2 to it, and we've halved it, and that's our new image point. And then the same thing for the y. We've done all this stuff to the y to get the new image. So I like to separate it out and say, well, x image is half x plus 2, and y image is negative 3y plus 1. And now you have to think a little bit, because we need to make a new equation. Our old equation was y equals root x. And people are going to substitute, people are going to put that into here and that into here. And that will be wrong, because this is y image. This is not y, and this is x image, not x. So if I said x plus 1, and I said, let's do a substitution, a equals 3, you would know that you would not sub the 3 into x. That would be silly, because a is not x. Well, by the same token, y is not y image and x is not x image. So what we need to do is rearrange. So I'm going to rearrange this. I get x equals 2x image minus 2, and I get y equals y image minus 1 over negative 3. And I'm going to leave that negative just down the bottom there. That works just fine. Now I'm going to sub it in, and I'll get my final equation. So now I can sub this into y, because this says y equals, and I have a y, so I can substitute that. So let's do that. So y image minus 1 over negative 3 equals root 2x image minus 2. So now we just want to make the equation look a little neater. I'm going to times by 3 or times by negative 3 on both sides. And I'm going to add 1 on both sides. And when we get our final equation, we don't want to put the image symbols on there. So this is the image symbol. Be careful, it's not negative 1, and so it's not the inverse. This is our inverse when we have to the power of negative 1, and neither is it when we have like f dash of something. That's when we're doing differentiation. So it's just y dash, which means the image. So now that I get my final equation, I'll get rid of those little dashes. Y equals negative 3 root 2x minus 2 plus 1, and that will be our final answer. And look, it doesn't take so long usually. Once you get the hang of it, it doesn't take so long. Just be aware, the important things there, the mapping. This is the mapping here. So mapping. So that is step 1. Step 2, we state x image and y image and rearrange. And step 3, we sub, and so we substitute those x and y values in with the image, and then we neaten it up. Sub and neaten it up, so we get our final answer. So that completes all the worked examples from 3.4.